I'm developing a game about exploration and discovery in a high fantasy world as part of a project I've been working on for the past 7 years. I'm planning to make one big game based on everything I learned as part of this project. It will probably take my entire lifetime, but I'm making my own game engine, I'm shipping builds, I'm making YouTube videos, and oh look, who left those subscribe and join the Discord buttons in the game's readme on GitHub? I wonder who that could have been. This week I trekked through the actual disgusting bowels of how computers get themselves to draw text properly. And it wasn't fun. It can't be that hard, right? There's only the alphabet with sprinkles, the German snaky snookies, the Asian clip arts, oh god, it just keeps going. Oh my god, there's more of them. What began with me trying to figure out why I couldn't properly render bullet points, specifically only on Windows, ended up with me having to slog my way through the entire code base to try and figure out why I wasn't able to render exotic characters since pretty much the dawn of text rendering. This is going to be a pretty big rabbit hole, so let's get started with the official Other Mythos UTF-8 primer. Computers do ones and zeros. You can combine these ones and zeros to get the computer to count. You can assign a number to each of the letters in the alphabet and get the computer to draw text properly. The Americans worked out this system called ASCII for assigning letters to numbers, and the rest of the English-speaking world being complete simps, they just copied them. However, should you decide to venture outside of the Anglo-Saxon land, things start to get very stanky very quickly. You are limited by the fact that 1 byte can only store up to 256 values. So most countries just came up with their own encoding systems for their different alphabets. And what that essentially meant was that if I tried to send my ASCII file off to Japan and someone there tried to open it, they'd probably find that it was all just completely scrambled because the computer would not know how to interpret it properly. But it didn't really matter because no one ever did that. And then the internet came along. You could just increase the size of a single character to be 16 bits, but then the problem eventually comes back round again anyway. And as most text in computers was just written in the Yee-Haw American text, also known as the English language, that would have just been very inefficient. Luckily, ASCII only used 7 bits, meaning you had the 1 bit left over, and as such, UTF-8 was born. You essentially just use the final bit to tell the computer that it should take the next byte in the row into consideration, and then look at this! You've got all these extra bits that you can just use to signify extra characters. And if you need extra characters, you just set that bit again, and you can just keep going. The most commonly used Latin characters get the most efficient 8 bits, and everything just works perfectly. Unless you happen to be using the world's most categorically worst piece of software ever written, an utterly grotesque blot on all of human achievement, and genuinely the biggest travesty of the modern computing era. And we do not speak its name, but it is probably the Microsoft product you're using to watch this video. Windows, for whatever reason, decided that the best thing to do would be to use UTF-16, that's 2 bytes per character, absolutely everywhere, essentially bucking the trend of what everyone else has done. Eventually, in the modern era, they kind of realised the mistake they made, so they tried to shift some of their API stuff to using UTF-8, but it's essentially too late because they also love backwards compatibility. So they've now got kind of 2 weird halfway house systems in place and have just made it worse. So basically foreign text didn't work on Windows and only Windows, and I had to spend 3 days of my life figuring out why that actually was. So I started off by writing a simple test program on a platform I knew actually worked. And then I moved that over to Windows and watched in amazement as it all magically blew up. I spent a bit of time with the C++ debugger just checking sure that the text from my scripting language to C++ had made the transition correctly, but what I was able to do was go into the Visual Studio memory inspector and actually look at what the bytes of memory were showing me, and they eventually ended up showing me that it was actually valid UTF-8 that was being received. So that was great. Because the thing was, what sort of threw me off was that the Visual Studio debugger just sort of garbled the text. So it was valid UTF-8, it just didn't really know how to comprehend it, which was pretty annoying. I mean, there might be some flag that I'm not aware of that you can trigger to set it to use UTF-8 by default, but you know, it just didn't work out of the box, which was quite frustrating because this is a fairly straightforward project. C++ is quite an old language, and back then there wasn't really a consensus on this is the character encoding you have to be using. So as a result, it was really up to the compiler to decide what to do. And that was my next hurdle, just checking that the compiler was doing what I thought it was. Oh, it took me so long just to figure out how to print like Japanese characters out to the console. I went as far as actually compiling a C++ binary inside a Docker container on my Windows system, so I could use all the Linux toolchains just to check it was doing what I thought it would. And it worked fine, like it printed the stuff out, but then you move that exact same piece of code over to Windows, try and compile it there, and it doesn't work, it just completely garbles it. Maddening. So here's another problem that took me a while to figure out. Windows has like 3 different consoles these days. There's the original CMD, PowerShell, and their new fancy one. All the other ones are using some god-awful, I don't know, they were probably just using regular ASCII. So it took me ages to figure out that I actually had to separately run the exe inside of the terminal before I even got sensible output. In Windows, in order to use UTF-8, you explicitly have to tell it to use it. And it took me a while to eventually find some guy's YouTube video where they told me how to do it. And I was genuinely happy at making even the slightest bit of progress. But really all I'd managed to do was print text out to the console. The rendered text was still completely broken. And at this time I had been testing the game on the Steam Deck with Linux, and I had come to a startling conclusion. For some reason it was broken when using the Steam Deck's like internal interface, but when you switched to the desktop mode, it wasn't broken, which told me something very important, which was that this was not a compile time issue, this was a runtime issue. And this caused me to question the GUI library I was actually using myself. And I became convinced that if I fixed the issue on Windows, it would also get fixed on the Steam Deck. So I moved all of my emphasis back to Windows and started trying to compile the GUI library's example project, because that way I could roll out all my own code. And testing foreign characters within the testing environment gave me the exact same problem, which was great because it showed it wasn't necessarily a me problem. And from there, I traced through pretty much every single line to figure out where things were going wrong. My first suspicion was FreeType, which is a library that converts vector fonts into like an actual texture that you can use to draw stuff. I was wondering if maybe it just didn't understand the font correctly, so just jammed these question boxes in place. But eventually I came to realize that it wouldn't be FreeType because FreeType wouldn't actually add new characters in. So notice there's 3 boxes for one specific Chinese character, which indicates that it's trying to draw a question box for each of the 8-bit blocks that make up the complete Unicode character. The next library was HalfBuzz, which is just a like text shaping library. What it essentially does is just generate a load of rectangles and then you can draw your FreeType textures onto that. That might sound really simple, but actually it's a very complicated problem, and HalfBuzz is one of those libraries that's basically just used in everything. I essentially ruled it out using the same method I'd used with FreeType, which is essentially just, why would it add new characters if it's a text shaping library? See, once I'd figured out that the question mark box had a name, which is the replacement character, I could just go back through the code base and try and find the bit where its value, which was 65533, was being introduced. And that led me to the ultimate culprit, which was a library called ICU, or International Components for Unicode. This actually just goes through and helps convert characters to like reliable Unicode. I didn't put it there, the GUI library did. And after a while, I ended up on the trail of something that looked pretty promising. ICU actually happened to have this concept of a Unicode converter, which was platform dependent, of course. And that was promising because it solved the issue of why this was an environment issue, not a compile issue. If the library had selected the wrong converter on an individual platform, then it would just completely scramble the text. And guess what? Okay, I think I might have actually found the difference. So the get default name on Windows is US ASCII, and the default name on macOS is UTF-8. So all I had to do was find the function that allowed me to explicitly tell the library which encoding to use, rather than just letting it take a stab at it. And then oh, it lives. I think I've done it. Oh, I'm gonna have a little cry in the corner now. God, that took forever. Yes! Yes! Oh! It looks kind of broken because I still have that testing thing in place, but test-door. Lovely. God, it only took 50 years. I mean, I'm almost in a state of shock that I actually managed to figure out how to get this to work. So I don't know why that was the default on Windows, but it ruined my life. I guess maybe we just shouldn't question it. It is Windows after all. But there must be some reason why it set that to be the default. This probably was a case of the people who wrote the GUI library didn't like properly test it on different environments or with different encoding systems, or maybe they just never tried foreign text. I don't know. but it did seem a bit peculiar. But it's definitely platform dependent, so maybe that has something to do with it. And for those of you who would say, oh, but the Windows operating system wasn't responsible for that, it was the library's fault, I would just say to that, the Windows operating system is so bloody inconsistent with using the different encoding systems that I'm sure the library was just like, oh dear boys, we're on Windows here, we better just take a stab at guessing what encoding system we're using, and ultimately bungled it. Like, yeah, ASCII, welcome back to the Y2K bug or something like this. So now, bullet points work properly in the game. That's it. That was all this was about. That's all this was ever about. So now let's talk about other things I got working. Firstly, full screen was improved yet again. Turns out I hadn't really been setting it correctly before. So SDL2 has this specific flag that you can set to do borderless full screen. I'd sort of implemented it before where I'd set my borderless myself and position my windows accordingly. The problem with that was that if you're on certain desktop environments, so like KDE on the Steam Deck or the GNOME desktop environment, it still had these title bars at the top, which just didn't disappear. So now I figured out how to set that correctly. That just works as expected. I should have just read the docs, mate. I've now properly finished off the command prompt and got my first initial commands in place. Honestly, I'm absolutely loving the Elite Hacker command prompt, it's amazing. But it's just things like you can go into it, teleport the player to the gateway. That's just so time efficient because I used to have to do that by hand. You can do things like give the player health, give the player items. And there's also this. You can give yourself a none. Look at that, that's my missing no item. How do I use it? Okay, that crashed the game. I should definitely add a little Easter egg there. What's my Easter egg going to be? Okay everyone, let's get some audience participation. Comment down below what the Easter egg should be when I actually try and use the none item. I'm thinking either something like kill the character, destroy the entire world, or do something really exciting. Like come up with the most outlandish ideas you can. And I'll put it into the game at a later date if I don't have any of the tech for that yet. Let's do set the player's health to be 1 to make it a challenge. Spawn enemies in current world. Use the none. Oh no! We now have a pause screen. I know, it's riveting. So press the escape key and have a good time. Bug fixes! The game is now much more stable and you go out of bounds. It used to just glitch horribly all over the place. Playtime is now tracked correctly, before it just didn't even try. Inventory saving is now properly in place and not broken, so you don't lose your items if you save the game. Wow, this sounds like a real alpha project. Testing is being improved. I've now got a test that goes through and places the player at each specific region, but I am having some problems with the test at the moment. The GitHub Actions pipeline is just a massive sea of red, because mainly that stupid goblin foot issue is still there, and I don't know what to do about it. The thing is, all in all, a lot has got done this month. It was the bug fixing and stability month. I've got a whole lot done, and a lot of it was just like infrastructure stuff, so like getting tests to work or getting the engine to be able to do foreign text or just, you know, anything like this. This is all stability stuff, and it's also stuff that the future projects I plan to make with this engine on this channel will just all get to benefit from it. Like I won't have to deal with getting foreign text to work ever again, which I don't want to have to do. I'd like to quickly mention my plan for the next month. Really, the plan for next month is combat. I've got some new ideas for things I'd like to try. You know, we might actually be approaching a different gameplay paradigm, but this is the sort of thing I'm really excited to test with actual open alphas, because that way I can get feedback from people very quickly. That's going to be amazing, and I just sort of did have to stabilize the game in the first place in order to get that stuff to work. So that's predominantly what I'm going to be doing next month. I'm really looking forward to getting back to gameplay, so I hope you are too. And you'd all better subscribe before it's too late. The other thing is I haven't had a proper alpha release in about 2 months now, as it's mostly just been stability and that sort of thing. So I decided that now was the opportune moment to release an alpha. So you can go and download alpha 0.3.0 in the GitHub releases page, which is linked down in the description.